So in this video, I want to talk about the graph of a function. And in general, we're going to talk about key aspects of a function or key concepts of a function, all right, key features. So the first thing we're going to talk about and what you learned earlier is what we're calling intercepts. And remember, an intercept is just where the graph crosses the either x-axis or the y-axis. So when we talk about this, an x-intercept is where the graph crosses the x-axis. So it crosses or touches. So we'll say it touches the x-axis. And when it touches the x-axis, at that point, it has a special value. It always has the value of whatever your x-coordinate is, and your y-coordinate would always be 0 because you're not moving vertically, you're just horizontal on that axis. The y-intercept is where it touches the y-axis. And again, just like the x-intercept, it's a special point because at this point, the y value is 0. The y value is 0. And you'll have the x value is 0. And you'll have a y coordinate for that point, the vertical movement there. So if you look at this graph, here's what happens. We can go and pick x-intercepts and y-intercepts from this graph. And if you notice this, if we want to find x-intercepts, we're looking at where it crosses the x-axis. So anything that touches the x-axis is going to be an x-intercept for us. So we have this point right here, negative 4, 0. We have this point right here, negative 1, 0. And we have this point right here, 4, 0. Notice that all of their y values are 0. So our x-intercepts here are negative 4, 0, negative 1, 0, and the value 4, 0. And notice that I wrote those as points because intercepts are points. And our y-intercept is where it crosses the y-axis. And here, notice it crosses the y-axis at this value down here, which is 0, negative 3. Now, I want you to notice that this graph has three x-intercepts and only one y-intercept. A function can have more than one x-intercept. However, it will always only have one y-intercept if it's a function. The other thing we're going to talk about now is the domain and range of this graph. Your domain is defined as the set of all x values. And your domains go from left to right. So it's the x-axis. So what you're literally doing is looking at the function, where is it starting at on the x's? And if we look at this particular graph right here, reading from the left side, we see that this arrow over here means that it's going forever in this direction. And this arrow up here means that it's going forever in this direction. And remember when we say those arrows, that means that this is negative infinity and this is positive infinity. So for this particular graph, the domain is all reals. And then the range is the set of all y values. So our range here, we define it as the set of all y values. And here, this is basically looking at the graph as it moves up and down. And so when we look here, we always want to write the range starting at the bottom first. And if you notice here, we're going to look at the graph again, and we're looking at what these tails are doing. Notice that this tail is continuing forever downward like this. And this tail is continuing forever upward like this. If we go forever downward, this is negative infinity, and forever upward, this is positive infinity. So our range here is also all real numbers. And so now we're going to talk about what we call function values. And function value, another name for that is what we call f of x. And remember, if you've never seen this, f of x really just means a function value, which is really a y value. And all it's telling me is that when I input, this is an input, when I input an x, I'm going to get back a certain y. And so to find function values from a graph, because that's what we're interested in, here's what we're going to do. we're going to first identify the input at x value. So identify the input. And in this case, that would be this value right here. That's the input. And then we're going to move up or down to a y value. So we move up or down to a y value. And that y value should correspond to my input value. So let's look here at this. The first example says f of -2. So what this really means is that x is equal to -2. So what you want to do is you want to come on your x-axis and find the value of -2. And so we can come here and we see that -2 is sitting here. We want to find the corresponding y value by moving down the y-axis to this value over here. And if you notice here is the y value that corresponds to that -2. It is -4. So this answer is just -4. On the next one, we see that we have f of 0. So here x is equal to 0. So again, here is the x equals 0 value. We want to find the value that corresponds to that on the x-axis, the y-axis. So that is here. That is the value of 4. And then finally, we have f of 1. So this means that x is equal to 1. So come over here to 1. And what we're interested in is the y value. You can see your y value here at 1 is actually going to be 0. And this means that this is technically this value right here is a x-intercept. It's a value of 1, 0. Another way of doing this is to actually write the point on the graph that you're looking at. So for instance here, that point is the point -2, 4. Notice that the x is -2 and the y is 4. This point here is 0, +4. Here the x is 0 and the y is 4. And then this point is 1, 0. Here the x is 1 and that is 0.